Dear students, in some of the previous modules, we have discussed about algorithms and how to represent algorithm using pseudocode. Today, we will talk about algorithm efficiency. So, in fact, the algorithm efficiency is a measure of execution time necessary for an algorithm to complete work on a set of data. So in computer science, whenever we talk about algorithm efficiency, we mean that the time which is required for an algorithm to complete the task. So although today computer science has evolved in such a way that today's computer can process billion of instructions in 1 second. However, still if you select the proper and appropriate algorithm for the task at hand, then it can ease the life and it will become very beneficial, as we will discuss in one of the example. So suppose your university registrar has a list of 30,000 students, and those 30,000 students have been sorted based on their registration number in ascending order. So this means that the registration number at the front or at the start or first is the minimum one, and then it is incremented until the last one. So now we want to search a particular student from that list. So in one of the previous modules, we have used a binary search algorithm. And we also discussed about sequential search algorithm. So the sequential search algorithm is searching the data starting from the first element until the last element. And we have learned that the binary search algorithm start comparing the elements from the middle. And if the middle element is greater than the searching term, then it skips all of the list that is preceding on the right side, and it only focuses on the list that is on the left side. So in such a way, this binary search algorithm works. So let's see if we use the sequential search algorithm on this data, and suppose the required student is lying at the last of the list. So this algorithm will start searching from the first node until it reaches at the end of the node, and it will require 30,000 comparisons. And suppose that one comparison is done in 10 milliseconds. So this means that 30,000 multiplied by 10 divided by 1000, because 10 millisecond is 10th part of thousands elements, and it will require 300 seconds, which means 5 minutes. So this would be very embarrassing situation for the registrar, that he has inserted a student name or student registration number in the list, and he or she has to wait for 5 minutes. So let's see if that particular registrar uses the binary search algorithm, which always start from the middle and then focus on the left side or on the right side of the list. So in every iteration, it is reducing the list by the factor of 2, which means it is only searching half of the list next time. So this means first time it has 30,000 elements, and in first comparison, it will only focus on only 15,000 elements, and in the third iteration, it will only focus on 7,500 list elements. So this means if you keep dividing 30,000 by 2, then there will be total 15 iterations that are required. And in 15 iterations, the required time would be 0.15 second to search a student that is lying at any place of the list, whether it's in the start or at the end. So this means this will be done in fraction of second, and registrar will get the information instantaneously, so it would be very good. So this means that selecting a particular algorithm that is efficient enough will ease the user and will satisfy the user as well, and it will save you time. So normally in computer science, algorithm is analyzed in 3 scenarios. We see the worst case scenario, average case scenario, and best case scenario. At the moment, the example which we have discussed, we have only discussed the worst case scenario, which means the element might be present at the end of the list. So let's see if the element is at somewhere in the middle of the list, which will be something called average case scenario. So on average, the sequential search algorithm will need to process 15,000 entries, and it will still need 2.5 minutes. So the average case scenario of sequential search algorithm takes 2.5 minutes. However, the worst case scenario of the binary search algorithm only takes 0.15 seconds for the same kind of data. So if we conclude today's module, we have learned about algorithm efficiency. We have discussed that the algorithm efficiency means the time required to perform a certain task on certain data set. And we have also discussed that why we need to measure the algorithm efficiency, and we have discussed this with an appropriate example and have really critically understood that the difference between sequential and binary search algorithm and their selection can ease the job of the university registrar.